For question 11, most of you did pretty well for part A, so I'm not going to elaborate on it. It's more on a recall, it's more like a recall question. B part 1, unfortunately there is a typo, and because of that, in the original prelim paper, we will void this question. All of you will get 2 marks. I just want to spend a bit more time on part 2. We practice quite extensively on how to attempt this kind of question using conservation of energy. So down here, we don't really need to state what is the new V1. We only ask you to describe. So when the oil flow faster, then obviously you would have a greater V1 as dictated by Faraday's law. But this question requires you to use the conservation of energy angle to look at the situation. So electricity essentially is just a way of transferring energy. So it means that V, voltage, is energy carried by a coulomb of charge. Meaning that if your V1 goes up, it means that there must be more energy transfer to the generated by the turbine. So where does the energy come from? The turbine can only generate electricity when you turn the turbine. So we would require you to state where the energy come from. In this case, the oil would travel at higher KE. This KE will be transferred to the turbine. The oil turns the turbine, and so the turbine will move with greater KE. And as a result, it can convert this higher kinetic energy into electrical energy, and that's all. So don't always think like, oh my god, this is going to be, I never see this question, it's going to be hard, I better write to a lot of things to it. Yeah, just keep it simple. Yeah. Okay, then for part 1, most of you are able to do this question without much issue. For C part 2, most of you got it correct, that direct current will not create any changing magnetic flux, and hence there won't be any induced voltage. Okay, so I think question 11 is quite straightforward, and most of you did pretty well.